In the question number 41, a force F 3I cap 4J cap Newton is acting on a particle. Work done by this force is 0 when particle is moving on the line 2y plus px equal to 2. The value of p is. This is very interesting question. So you will see how I am going to solve. Suppose force dot displacement. So I can write f t cos theta. This is the formula. Work done. According to the problem, work done is 0. So I can write f d cos theta is equal to 0. So you can find theta will be 90. So I can say force is perpendicular to the displacement as per the discussion according to the problem. And we know that if two slopes are perpendicular, then we can write m1 into m2, that is equal minus 1. Right? But question is that how we can solve m1 and m2? No problem, because slope is calculated by tan theta. m1, if I go for the force, then you can see 3i cap plus 4j cap. So tan theta will be the coefficient of j cap to the coefficient of I cap. So m1 is equal to 4 by 3. And now m2 I am going to take for the displacement, because we need only two things. As I said, force and displacement are perpendicular. So m1 for the force and m2 for the displacement. So if I change this equation, I can write 2y minus px plus 1. So y is equal to minus p by 2 into x plus 2. If I compare with mx plus c, then we'll get m is equal to minus p by 2. As I said, this is m2. So now we have the value of m1 is 4 by 3, m2 is minus p by 2. If I place here, m1 is 4 by 3, m2 is minus p by 2, that is equal minus 1. So minus minus will cancel out, 2 2 ja 4. So we have p is equal to 3 by 2. So this is what I am trying to calculate. So I can say my option number 2 will be the right choice. Let's move on question number 42. In the question number 42, a 5 kg block is connected with two springs A and B having force constant 200 Newton per meter, K2 300 Newton per meter respectively as shown in the figure. The block is released from rest. Both the spring in natural length, the maximum elastic potential energy stored in the spring A and B. Okay, suppose if I consider this block is going to downward and the displacement is x. So B spring will compress and A will elongate. So if I use the law of conservation of mechanical energy, as I told you in the previous questions, then I can write by the law of conservation of mechanical energy for A half K1 x square plus second one half K2 x square, and that is equal mgx, as I said. So this is the equation. By this expression you can solve this question very quickly. X square will cancel out. If I take x as a common, so we'll get k1 plus k2. And this 2 will move on the right hand side, so you have 2 mg. I need only x, so 2 mg upon k1 plus k2. If I put the value, 2 into mass is 5, g is 10, k1 and k2, 200 plus 300. So that will give you 1 upon 5 meter. This is the elongation in spring A, as I said. And question is asking to us maximum elastic potential energy stored in the spring A will be. So potential energy on the spring A is half. I am going to write the value of K for A, that is 200. And elongation, you have 1 upon 5 as per my calculation, 1 upon 5 square. So when you will solve, you will get 4 joule. So this is the potential energy stored in the spring A. So my option number third will be the correct choice. Let's move on question number 43. In the question number 43, this is a basic question. An electric pump on the ground floor of a building taking 10 minutes to fill a tank of 45 meter cube. This is the volume with water. If the tank is 20 meter above the water level, if electric power consumed by pump is 30 kilowatt, then efficiency of the pump will be, and water density is 1000 kg per meter cube. So you can solve this question by using the formula directly. In terms of percentage, efficiency means output to the input into 100. So if when you will go the output, then you will write volume into density. So that will give you the mass multiplied with 10, because question says the tank is 20 meter above the water level. So this is the work done, mgh. Divide by the time, but before dividing the time I need the input. Question says 30 kilowatt. So I will write 30 kilo means 10 to the power 3, 60 into 10. So when you will solve and multiply it with 100 for the percentage, you will get 50%. So in this type of question, you can use the formula output to the input for the efficiency. So you will get 50%. So my option number third will be the right choice. Let's move on question number 44. In the question number 44, if two vectors are given A and B, this and this, the unit vector perpendicular to A and B is, A cross B is equal to magnitude of A, magnitude of B into sine theta with the unit vector in the case of cross product. Or I can write unit vector A cross B divided by A cross B in terms of magnitude. Simply, you need first A cross B and then magnitude. So when I will go for A cross B, you just use determinant method as I used in the previous one. I, J, K. I need A, 1, minus 1 and 2. For the B, I plus 2J plus K, 1, 2, 1. When you will take determinant method, you will get 5I cap plus J cap plus 3K cap simply. And when you will go the magnitude, you will get root 35. So I have A cross B magnitude and A cross B. When I put in the equation number 1, will get the value of unit vector. So finally C unit vector is equal to minus 5I cap plus J cap plus 3K cap divided by root 35, and this is our final value. So I can say my option number 1 will be the right choice. So let's move on question number 45. In the question number 45, the linear density of rod is 2 meter, whereas the lambda is given 2 plus 3x, where x is distance from end A, the distance of center of mass from the end B. The distance x is from A, but question is asking to us from B, so you have to be very careful. And first I will use the formula of center of mass for continuous body, and that is x dm, only dm with the integration. So first I need the value of dm. Dm means lambda into dx, you know very well because the linear mass density is given, and that is 2 plus 3x into dx. So when I will put 2 plus 3x into x dx, limits are 0 up to 2 because the length of the rod was 2 meter, and divide by 0 up to 2, 2 plus 3x into dx. So when you will integrate x square plus x cube, limits are 0 up to 2, and 2x plus 3x square by 2, 0 up to 2. So when you will use the limits, you will get 4 plus 8, upon 4 plus 6. So that will give you 1.2 but from A. But I need from B. So how you will get? Total length is 2 minus 1.2. So that will give you 0.8 from B. So by this calculation I can say the center of mass from the end B is 0.8 meters. So my option number 2 will be the right choice. So thank you, and we'll meet again for the next AIATS. Thank you.